All right, welcome to Chapter 5, Section 3, Angles of Triangles, and this is for Math 8. So a couple things you'll see on the screen here, just like always. The first thing you should see as a student is a due date. I don't see that in the teacher preview, but you'll see it on your side. The number of attempts here, we always have unlimited attempts. You can come and try this assignment as many times as you would like. That's true for tests and quizzes as well. Number of questions, there is always, not always, sorry, it just depends on the section. For this particular one, there's going to be 6 questions. Grading policy is best score, so whichever attempt is the best one is one you keep. And partial credits enabled, so if you answer 1 of 6 questions correctly, you get to keep the points for the one question, or however many you answered correctly. So please remember, once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start down here, it looks like I kind of cut that off a little bit with my screen, but down here in the bottom. In the bottom right corner here, there is going to be a submit assignment button. Even though it's cut off here, it's not on my screen for the teacher, but it will be on your screen for the student. So you always want to click that button when you're ready to leave the screen. Whether or not you've started any of these, or if you've started a few or all of them, you want to click that button. In order for it to save your place, you do need to make sure you have the green check mark. You can't fill out part of it. You need to actually fill it out and click check to get the credit for that problem. But it will save your place as long as you have a green check mark and you don't have to do that again. The other thing it does is it stops the program from locking you out of all of your other assignments, just like that other screen said, because it assumes this is what you want to come back to next. The other thing it does is it affects the grade book, so your teacher can actually see what you've been working on. Until you click that submit assignment button, it's kind of just paused. So just good habit, always click that button. On the side here we have explanation, example, and message center. So explanation tells us we're going to lose our question attempt because it's going to give us the answer to this question. So it's not going to give you the answer and let you come type it in. You're going to have to come in another attempt to try that. But example will give you a very similar example. So problem type, exactly the same, or not exactly the same, but same problem type is what we're looking at. And it'll walk you through it. You can click example again to get another example if you'd like. You can also message your teacher directly from the screen so that, hey, we know where to come help you if you get stuck, if you need some help there. All right, so when we're talking about angles of a triangle, we want to understand one of the basics here. And the 3 angles of a triangle always add up to 180 degrees. So I'm actually going to pop over to another screen because there's a cute little graphic that I like, so I'm going to show you that. Okay, so on this screen, and this is actually not my video, I'm borrowing this from www.tapintoteenminds.com. It's something you can find on YouTube. It's just a very nice little visual so that we can see what's happening. So we have a triangle with ABC here, and what it's going to show us is the interior angle sums if they take them apart. So we can see the yellow, the orange, and the green. If we take them apart and we put them together, they are on a flat line, which is the definition, and they did that really fast, so I'm going to go back to it. This is the definition of a straight line is that they add up to 180 degrees. So this is just a very cute, very quick little visual to show you that if you take the 3 angles of a triangle, they will always line up to create a flat line, or they'll fill in all the blanks here to create 180 degrees. So now that we've looked at that graphic, we're going to go ahead and start looking at this piece. So we know these 3 pieces have to add up to 180 degrees. So 80 plus 40 plus x, there are my 3 angles. If I add them all together, they give me 180 degrees. So if I add these 2 together, 80 plus 40, that's 120 plus x. So of the 180 that I have available, I'm already using 120. So I'm going to subtract this 120 from both sides. I know it's a very ugly x, but and we're going to cancel out. 120 minus 120 cancels. X equals, so 180 minus 120 is 60 degrees. That's all that's left over for x. X has to be 60 degrees in order for these guys to add up to 180 degrees. All right, let's keep moving here. So for the exterior angle theorem, this one is directly related to the triangle angle sum theorem. If these 3 add up to 180 degrees inside the triangle, like this, they add up to 180 degrees. It'll say add up. So that's my dorky way of saying add up to 180 degrees. Well, then we also learned a few sections ago that a flat line also adds up to 180 degrees, right? So if these 3 angles add up to 180 degrees and these 3 angles add up to 180 degrees, what we want to pay attention to is, what do they share? Well, they share this angle right here. They both have this same angle in them. And I can go like this, A, B, C, and we'll call this one D. So if I go A plus B plus C, those equal 180 degrees. And then I could also just say C plus D equals 180 degrees. So they both equal 180 degrees. And I'm adding C to both. So I can actually replace part of this if I know, if I use substitution. So I'm kind of explaining why this exterior angle theorem works the way it does. So I can actually replace the C if I use some substitution here. So I'm actually going to solve this guy for C really quick. So D minus D cancels, and I have 180 minus D. So now, I'm going to switch my color again. I have C equals 180 minus D. I can substitute these for each other. I know that C equals 180 minus D. So now I can put 180 minus D equals 180 and then A plus B, because these guys just come down. And actually here, I'll put this in pink just so that you can see the only thing I'm replacing is the C. The rest of it is just going to come down just like it was before. So I'm just, instead of C, I'm replacing with this 180 minus D. So now what I want to do is move the 180s together. So I'm going to subtract 180 from both sides. I have A plus B minus D, because the parentheses just drop away. The parentheses were just to show that it was kind of together as one piece. 180 minus 180 cancels, 180 minus 180 cancels. So we get 0. So A plus B minus D equals 0. So let's go ahead and put this on the other side here just so that we have all positives. So I have A plus B equals D minus D cancels D. So this is actually the exterior angle sum theorem. Or exterior angle theorem, sorry, not sum. Saying that the two remote angles, A and B, add up to the exterior angle. So we kind of went through and I showed you the proof on why, because I can replace C with the 180 minus D, the 180s cancel, and then if I move D to the other side just so that it's positive, I can see that A plus B does in fact equal D. So kind of a roundabout way to get there, but the whole reason is because we have them both adding up to 180 and they share this piece. So if C plus D equals 180 and A plus B plus C equals 180, well, if I just take this out, then they must be the same. A plus B must be the same as D, since they add up to the same when I add C to both of them. So it's just one of those kind of, sometimes it's hard to think of that logically, to say, oh, well, if they both share C, then I can just ignore the C. It's not always that easy to necessarily think of it that way. I started to twirl this a little bit. I didn't mean to. Untwirl. There we go. Okay, so A plus B equals D. We know that already, and guess what? They gave me A, B, and D if I'm thinking of the same diagram I have here. So I can go 85 plus 57 equals X. All I have to do is add these two pieces together. So I get 12, 8, 9, 14. So I get 142. So it's kind of a roundabout way to get to the exterior angle theorem. How do we know that they're equal to each other? And it's because we can use the triangle angle sum and this 180. So could I have done this differently without knowing the exterior angle theorem? Of course. I could have said, well, what does this angle have to be? If I had 57 plus 85 plus, we'll go question mark. I'm going to pretend like that's a question mark there. That equals 180. So I'd have to add these guys together, which would be 142 plus question mark equals 180. And then I'd have to subtract 142. So I'm just solving for this missing angle here. And I get that missing angle is going to equal, let's see, what is it going to equal there? 10, we get 8, we get 38. So this missing angle here, which I have marked C on this one, would be 38 degrees. And then I could use the straight or linear angles to say, well, these two have to add up to 180 degrees. So 38 minus 180 brings me back to 142. So you could have used both of those theorems, but the exterior angle theorem makes that a little easier if we can remember that exterior angle adds up to these other two angles, and we call these the remote angles, the ones it's not touching. And I always explain that in class. We call them remote angles, and you can think of a remote on a TV. The whole purpose is you don't have to touch the TV when you're using the remote. You can sit on the couch and change the channel. So same idea here. These remote angles aren't going to be touching this angle. They're the ones that aren't. They're across the triangle from it. All right, so now we're going to get into parallel lines a little bit. So we have the figure below. L is parallel to M. So remember, this means parallel these two straight lines. And they want us to find X here. So we're going to have to go back to a few of our theorems that we had before when we were looking at parallel lines. So I'm kind of drawing these in different colors here. Sorry, they should be touching there, but that's all right. We're just going to pretend like they are. So we have 96, we have 39, and we have X. Should you always draw the diagram so that you can mark it up? Yeah, I highly suggest. If you do not already have it printed on a page, if it's not on your notes page, I would definitely draw the diagram because it's much easier to mark up if you can draw on it. It's much easier to remember all the pieces here too. All right, so if we have parallel lines, which they told us we have parallel lines, remember if we have a pair of parallel lines and a transversal is just a line that crosses, so the blue line, even though it doesn't continue, it could continue going this way and it could continue going up this way. So could the red one. The red one could keep going across. So they're not there, but they could continue to go if we actually continue the lines if we wanted to. So we're going to look at those relationships that happen when we have parallel lines and a transversal. If you don't remember those, I believe that was in section 1. Let me see, in section 1, that video, I went over these in pretty good detail for about the second half of that video. So if you don't remember these angles, if this doesn't sound familiar to you when I'm going over this, go back to section 1 and rewatch that video so that you can remember those. Also, make sure you have your notes open with you because that on your notes page, there should be diagrams that show you these same angles and the relationships that go with them. All right, so we want to get from this point up to here. So if I focus on this red one, this is going to be my transversal for right now. The pink lines are always the parallel ones for this diagram, but I could focus on the red one for a transversal. I could also focus on the blue one. Just depends on what I'm focusing on there. So if I'm looking at this piece here, this red line, and I guess I can leave it in orange. We have this angle here, and this is the interior. And I'm just going to go int for interior. Exterior would be outside of the parallel lines. Interior is between them. So I'm in between the parallel lines, so I'm considered interior. So we have something called alternate interior angles. So I'm already interior. Alternate means go to the other side of the transversal and slide down as far as you can go, and you have this other side here. So it's not just the 96 or the 39. It's actually the entire angle that matches. And when we have alternate interior angles, and this is very shorthanded. Alex starts to do this over time too, where instead of writing out alternate interior, they'll go alt-int, like that. It's just, and then angles is the angle symbol with an S in there. So we have alternate interior angles, and they are congruent. Congruent means they're the same size and shape, which also means if we know the angle measure, they're going to have the same angle measure, because that's the same size and shape. So this whole thing is X, and that has to equal these other two added together. So we're using alternate interior angles to get here, but we're also using angle addition. Because I know that this one, and if we were doing this in a proof, which I think we will start to get to proofs in a little bit, I don't think we get fully into proofs in 8th grade, but in proofs, you have to say, why am I doing things? So I'm adding these together because they equal this entire angle here. So this is angle addition. I can add the two small pieces to get the entire big piece, or the entire big angle. So that's a big part of geometry, is not only what can I do, why am I doing it? What's the reasoning behind it? How do I know I can do that? So I have to be able to identify these. There's definitions and theorems and postulates, and there's all kinds of reasons that we can use on why we're doing something. So now that I have it set up, all I have to do to find x is simply add these guys together. So we get 15 and 13. Oh, that zoomed out. Don't know why that zoomed out. Check. All right, why did it not check? There we go. Okay, so now we're going back to the triangle here. So in the triangle below, angle J is a right angle. Suppose that the measure of angle H equals 3x plus 20 degrees, and the measure of angle I equals 4x minus 7. So there's a difference between just angle and M angle. So this is just talking about a shape. When it says, you know, angle J is a right angle, it's talking more about the shape of the object. When we have measure of in front of, we're actually talking about the degree. What is the actual measurement? So it's just the difference in, you know, using those symbols here. So first it's asking us to write an equation to find x. Make sure you use an equal sign in your answer. So if we're looking at a triangle here, remember they have to add up to 180 degrees. So angle I, and I'm going to change my color there because sometimes writing the gold is a little bit too much here. So angle I plus angle H plus angle J equal 180 degrees. The three angles have to add up to 180. So now I know angle J is a right angle. So if we don't remember, a right angle, we can see this little corner piece here, this little square. That means that it's 90 degrees. So I know the J is 90 degrees. I, they told me, is 4x minus 7. And they have it in parentheses here. The parentheses just show that it's a unit, so I don't really need to put the parentheses there. And then H is 3x plus 20. I'm going to put a plus sign there just so that it's not 2090. We don't want that much. So now I have H, and I have J. So I have these three pieces. Again, the parentheses just show the kind of each term or each angle, but you don't really need to leave the parentheses there. Because they just drop away anyway since it's all addition subtraction here. So we're going to add like terms. So we get 4 plus 3 is 7x, and then I have negative 7, positive 20, and positive 90. So let's see, that would be 110 if I did 90 plus 20. Minus 7, that gives me 103. Equals 180. So I think, let's see, I'm wondering if they want it reduced at all, because I started to reduce this. I'm just curious, let's see. No, they actually wanted them in parentheses here. So we actually want to go back really quick before I get too far. And I want to show each one of these in their parentheses. So here's angle I plus angle H, which is 3x plus 20, and then plus 90 equals 180. So they actually told me to use the equal sign. I need to make sure that I'm showing that it equals 180. So I needed to type this in really quick before I went too far. Now I can go through and start solving for each angle. Well, I already know angle J equals 90. That's what a right angle means. So I'm just going to fill in H and I here. So I have to solve for x because they both have an x in them, and then I'm going to go back and plug it in. Doesn't want to know what x is. It's not actually asking me what is x, but I need x to fill this in so that I can go 4 times whatever x is and then subtract 7. 3 times whatever x is and then add 20. But if I don't know what x is, I can't do that. So we need to make sure that we solve for x really quick. So we get, boop, 7x, 103 minus 103 cancels. And let's see, we get 7 and 7. Ooh, perfect. So that's going to divide by 7 nicely. 7 divided by 7 is x. 77 divided by 7 is 11. All right. And remember, we're always using PEMDAS, opposite operations. So PEMDAS we used up here to simplify, adding like terms. And then we start to solve by doing opposite operations. That's why I subtracted the 103. I divided by 7 because it was being multiplied. So you're always using opposite operations until you get that variable all by itself. You're doing the opposite of whatever is being done to it. Because that moves it from where the variable is to the other side of the equation. That's what the opposite operation does. All right, so we know what x is. Now I'm going to go back and look at, I have angle I, and that's the measure of angle I, equals 4x, minus 7. And we want to make sure that we bring this 11 right here. So it's going to be 4 times 11 minus 7. So we have 44 minus 7, and let's see, that would be 37, I believe. So angle I is 37, and then measure of angle H equals 3x plus 20, and again, we want to bring this 11 over here to the x, plug it in, so we get 3 times 11, and then I'm going to add 20 to that, plus 20. So I get 33 plus 20, so that's 53. 53. So one thing to do too, and you can click check here, and Alex will tell you whether or not you're right or wrong, but if you got the wrong answer, one thing you can check to make sure is these should add back up to 180 degrees. If they don't, something went wrong. So they definitely need to add back up to 180 degrees. And I know 53 plus 37 gives me 90, and 90 plus 90 gives me 180. So it's just one of those things. You can check that really quick to make sure before you click the check button. But Alex is pretty nice about letting you go back and check again. So, all right, we're going to take a look at this, guys. So we don't really need the marker board too much for this one, I don't think. So on this one, this is kind of like what we would call a paragraph proof, meaning that we're going to walk through piece by piece and prove something, but it's not in what we call statements and reasons. So I can actually scooch this over just a little bit. We usually have a statement and a reason column like this. In a proof, this is the way that I like to do it. And I have one, here's my statement, here's what I'm going to say. So angle 2 and angle 4 are, and we would choose something in here. And because we know what they are, then we can say, that they're either complementary, supplementary, or congruent. So when we do this in a statements and reasons, we do it a little differently. This is quite literally sentences, which usually we kind of put together more in a paragraph. But it's not 100% my favorite one to grade on paper, because sometimes things get a little bit jumbled and squished together. It's kind of hard to find all of the pieces here. Okay. So with this one, now I have the figure here, and we want to make sure we're paying attention to what it's saying. So lines L and K are parallel. So here's L, here's K. So I have line L and K are parallel, and those are parallel marks. When you see the arrows like that, doesn't matter what color they are, just when we see the arrows like that on lines, it means they're parallel. Suppose that angle 4 is 45 degrees, and angle 1 is 61 degrees. So now we're going to go through and fill out this piece over here based on the information they just gave us. So let's scooch this over a little bit so I can see more of the diagram there. So angle 2 and 4, I'm going to change this up to pink. So we have angle 2 and 4 are somehow related here, and we have this drop-down menu that we can choose from. So if these are the parallel lines, then this is interior, and the exterior would be up here and down here. Okay, so we have interior and exterior. So just to kind of throw quick labels on that, I'm going to undo that just so that they're not in the way. So we have interior angles, and I'm on the right side of the line. If I come over here to the left side and I slide all the way up, I do in fact land on angle 4. So angle 2 and 4 are what we call alternate interior angles. And we know from section 1 and I think section 1 and 2, if I remember correctly, that alternate interior angles are congruent as long as we have parallel lines. So if angle 4 is 45 degrees, then angle 2 must also be 45 degrees. So we see, and I'm going to write 45 degrees in here, that this is bugging me just a little bit. I'm going to move it off because I can't. It keeps getting in my way there. We see that angle 1 and 5 are something. So let's go with another color here. So we have angle 1 and angle 5 for these ones. Sorry, I was pointing over here. That's an L. 1's down here. So with these ones, they're both on the same side of this transversal here. And if you notice, I'm switching transversals. The transversal for 4 and 2 is this one that's going kind of more toward the right, or going kind of positive this way. Well, now I'm looking at this one as the transversal. So it just kind of depends on which one you need to be the transversal at that particular moment. So now I'm looking at this guy as the transversal, and they're both on the same side. So they're not going to be alternate exterior, alternate interior. And 5 is exterior, 1 is interior, so I wouldn't be able to categorize it as either interior or exterior. I have one of both. So what I want to do is kind of look at the position they're in. So they're both to the left of their transversal, and they're both above their parallel lines. We say that these are in the same relative position, or corresponding angles. And if I could, I don't know if I could actually do it, but I think there is a lasso type thing. Let's see, I wonder if I could nicely do this like that. Let's see if I could take this. Nope, no. That's not what I wanted to do. I just wanted to move it. So I could actually move this guy right down here, and you see how it fits so perfectly right on top of angle 1. So it's definitely a cute little visual to do it that way. Where corresponding angles are also congruent to each other. So we know that angle 1 and angle 5 are corresponding. And because we have parallel lines, they are congruent. And we saw that because I literally kind of cut it and moved it down. So if angle 1 is 61 degrees, angle 5 is also 61 degrees. All right, so now by the angle addition property, angle 5 plus angle 4 plus angle 3 have to add up to what? So if we're looking at, let's see, what color have I not used? We're going like this, angle 5 plus 4 plus 3. Well, they're asking us to pay attention that they're on a straight line together, and they completely fill in all the entire angles there. So remember, a straight line adds up to 180 degrees. So that's what they want us to acknowledge, that it's 180 degrees there. So then they're asking us, since we know that angle 5 is 61 and angle 4 is 45, what is angle 3? So they want us to actually go through and solve this. So 61 plus 45 plus angle 3 equals 180. So let's see, we get 6 and 10. So we're going to subtract 106 here so that we can get angle 3 all by itself. Whoops, moving the background there. Angle 3 equals, so let's see, we get 7, that's 4, and 74. So angle 3 equals 74 degrees. So now, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals, so if we think about this, I have 3 different angles here. I have 45 and 45. Oh, I don't know why that first circle went in the wrong color. 45 and 45. I have 61 and 61, and then they both share this 74. So if 61 plus 45 plus 74 add up to 180, well, the same thing would happen here. It's 61 plus 45 plus 74. So they would also add up to 180. So what we just proved is the relationship between angle 1, 2, and 3 is an example of the following rule. The sum of the interior angle measures of a triangle is 180 degrees. So we proved that the 3 triangles or the three angles in a triangle add up to 180. That's what they were having us prove there. All right, let's see. What's the last one here? We're going to prove the exterior angle theorem on this one, I believe. So let me get a picture, because again, it's very nice. You can draw the picture if you have the option of having it printed for you. Hey, that's very nice, but it's not always easy to print these out when you're working on ALEKS. So definitely, you know, if you can just draw it, that also works. This one's pretty darn easy to draw. I didn't really need to take a picture of it. Okay, so with this one we have, suppose in the figure, angle 2 equals 41 degrees and angle 3 equals 78 degrees. And then we're going to go through and fill in some blanks, and I can see from the diagram and from what we learned in this section, we're going to be focusing on the exterior angle theorem. We're going to prove something about it. So the sum of the interior angle measures of a triangle must be, we just proved this, 180 degrees. At the beginning of the video, I showed you that cute little diagram too, where you can take the three angles and put them on a flat line together. So angle 2 plus 3 plus 4 must add up to 180 degrees, since those are my three angles. We are given that angle 2 equals 41. So I can see that angle 2 equals 41. They told me that. So the measure of angle 3 and 4 equals, they don't want us to focus on the 78 yet. What they want us to focus on is if they have to add up to 180 degrees and we're using 41, what's left over for these two? Not necessarily focusing on the 78 yet. So with this one we would get, let's see, 139, sorry. So we get 139 for this total, both of these added together. And then angle 1 plus angle 2, if we're looking at these guys, also have to add up to 180 degrees. Since angle 2 is 41, it must be that angle 1 is, well, we would do the same thing here. 180 minus the 41 would tell us what's left over for the 1. So it's also going to be 139. Oh, sorry, that should be 180. I typed it wrong there, 180. And then this is 139. So therefore, the measure of angle 1, and we have to choose. And if we're looking over here, we have the measure of angle 1 and the measure of angle 3 and 4. Remember, the measure of angle 3 and 4 is 139, and the measure of angle 1 is 139. So we just worked that out. They're both the same, which means they're equal. They're not greater than or less than each other, as long as we're combining the two angles here. So this result is an example of the exterior angle theorem property of triangles. For any triangle, the measure of an exterior angle is less than the sum of the measure of its two remote angles, is greater than the sum of the measure of its two remote angles, or equals the sum of the measure of its two remote angles. And so it's always equal to in this case. But make sure you're paying attention to, you know, the wording there so that you don't mix them up. But this is the definition for exterior angle theorem. All right, let's go ahead and click check. Yay! All right, that was section 3. I will see you in section 4.